This is going to be our third day on section 2.2, and today what we're going to do is look at what's called intercept form. So our objective for today is the student will be able to work with intercept form and graph quadratics in intercept form. So intercept form is written in this form where a, the number in front, x minus p times x minus q, where a is not equal to 0, because if that was 0 it would make the whole thing 0 and we wouldn't have a quadratic. And p and q are the x-intercepts. Now, on page 59 in the textbook, they go through on the core concept, and they have a well written out instructions on this. So let's take a look at it. Again, we've got the intercept form. So properties of the graph of f of x equals a times x minus p times x minus q, which is our intercept form. Because when f of p equals 0 and f of q equals 0, p and q are the x-intercepts of the graph. So remember, the x-intercepts of the graph are where it crosses the x-axis. And so if we know where it crosses the x-axis, in this case we've got these points here, which we don't know what p and q are right now, but we do know that when we draw our parabola, whether our parabola opens up, or if our parabola opens down, it doesn't make any difference, but our vertex is at that turning point, and your axis of symmetry has to go through there. Now remember, when it's symmetrical, that means that every point that's of the same height here and here has to be the equal distance from that axis of symmetry. So when we take our x-intercepts, so that's when y equals 0, those have to be the same distance. And so we can use this. It says the axis of symmetry has to be halfway between p0 and q0. Okay? Because again, our x-intercepts, so y values are 0. So the axis of symmetry then, since it's halfway between there, we can find those by using this formula. P plus q divided by 2 would have to give you the axis of symmetry. And then whether the parabola opens up or not, remember that doesn't change from everything we did before. If a is greater than 0, then our parabola opens up. So this one would be when a is greater than 0. And this one would be when a is less than 0. It's going to open down. So we've looked at that. So now let's look at the example number 4 on page 59. So you can see on example number 4, we've got this equation. I'll just write it a little bit bigger. Negative x plus 3 times x minus 1. So remember, these are our x-intercepts. Now remember, it's opposite what it says because it's supposed to be x minus p. So we have an x-intercept here at negative 3, 0. And we have an x-intercept here at 1. So we have those points. So now what we can do, since we know the axis of symmetry has to be halfway between those, we just take p plus q and we divide it by 2. So in this case, negative 3 plus 1 divided by 2, so that would be negative 2 divided by 2 would be negative 1. So now we know our x value of the vertex. So that's at negative 1. Now we simply plug negative 1 back in. So we're going to plug negative 1 in here. Negative 1 plus 3 would be 2. And negative 1 minus 1 would be a negative 2. And if we multiply this all together, 2 times 2 times 2 is 8. And then we have 2 negatives, and so that's a positive 8. And so now we can label our vertex at negative 1, 8, and we can draw the graph. And we're done. So again, you find the values for p and q. You add them together to get your axis of symmetry. Okay, this negative 1 is our axis of symmetry. And then we plug that negative 1 back into the expression to find our vertex, and then we can draw our graph because we have 3 points. So they're going to ask you now to look at the MPs 6 and 7. It's on page 59, but I put it on here. So what I'd like you to do is try these, find the axis of symmetry, the vertex, and then draw your graph. And then, so pause the video here and then come back and look and see how you did. So we know on this that our vertex, or our p-value, so our p is -1, our q is -5, opposite what it was. So if so we know it's going to cross there and there. So now we find the halfway point. So -1 plus -5 is -6. Divide that by 2, and so we get -3. And so now we know that it's halfway between. Our axis of symmetry is here at -3. Now we simply plug that -3 in. So I'm going to plug it in. -3 plus 1 is, we got the negative sign in front, -3 plus 1 is a -2. And -3 plus 5 is a +2. And so if we multiply this together, we get 2 times 2 is 4. 2 negatives is a positive, so we know that our vertex is located at -3, 4. And we also, if we go to -3, our vertex is there. So now we can draw our parabola through those points. And it opens down, and that negative sign is what it should do. It should open down, so we now have our graph. So now let's try the next one. So again, we find our p-value. Remember, it's opposite what it says, so that should have been 6. Our q-value is opposite this, so it's 2. So we now know it crosses at 2 and 6. Our vertex has to be halfway between, so 6 plus 2 divided by 2, that's 8 divided by 2, so that means it's 4. So our axis of symmetry is at 4. So we've got that. Now all we have to do to finish this is find the vertex. And so we're going to plug 4 in. So 4 minus 6 is -2. And 4 minus 2 is 2. And 2 times 2 is 4. And 1/4 times 4 is 1. And we have 1 negative, so it's -1. So we had our axis of symmetry was 4 and -1. So that puts it -4, -1, and it opens up. And so that's all you have to do on those. So now let's look at a story problem, example number 5 in the book. All right, so example number 5, solving real-life problems, modeling with mathematics. The parabola shows the path of the shot of your first golf shot, where x is the horizontal distance in yards and y is the corresponding height in yards. The path of your shot can be modeled by the function f of your second shot can be modeled by the function f of x equals -0.20x and then x minus 80. Which shot travels farther before hitting the ground? Which travels higher? So, understand the problem. You're given a graph and a function that represents the path of 2 golf shots. You're asked to determine which shot travels farther before hitting the ground and which shot travels higher. Make a plan. Determine how far each shot travels by determining the x-intercepts. Determine how high each shot travels by finding the maximum value of each function. Then compare the values. So, if we look at the first one, our shot, it's modeled by a graph. We know that we started at 0 and we ended at 100. So if we do our x minus p That's x minus 0 and x minus 100. And we can write x minus 0 is just x, so that would be x, and then x minus 100. We also know that it went 25 feet high. So when we plug in our midpoint, that would be 0 plus 100 divided by 2, which would be 50. We know that when we put 50 in here, for the x value, we have to get 25 out for the y value, the height. So if I plug this in here, we know that we have to get 25, so we can find that a value. Okay? So we're plugging in 50, so we get a times 50, and then 50 minus 100 is a negative 50, and so we get a equals, a times 50 times 50 would be a negative 2500 equals 25. And now we divide by negative 2500. So we get A is that would be negative 100, so negative 0.01. Okay? So now we have that equation. That would be f of x equals negative 0.01x times x minus 100. Okay? The second one, we know that we have 0 and 80. So we know we're here at 0 and we're here at 80. And so our midpoint would be half of that, so 40. And so we can plug that 40 now into the formula. And we get, if we plug that in, they show right here. They plug it in and they get 32. And so the maximum height of the second shot is 32. So now if we go back to what they ask us to, which shot travels further before hitting the ground and which one travels higher? Well, we know that the first shot went 100 yards, so it went further, but it only went 25 feet high, and we found that the second shot went 32, so the second shot was higher, but shorter. It says the graph of your third shot is a parabola through the origin that reaches a maximum height of 28 when x equals 45. Compare the distance it travels before it hits the ground, and write the distance of the first two shots. Before it hits the ground with the distance of the first shot. They want you to compare it. So try it, pause the video, try this, and then come back and see how you did. So on this one, we know the maximum height is 28. We know it starts at 0. It goes to 28. But we also know that that is 45 feet out. So our vertex is at 28.45. And so remember, if that's halfway, then we know it's going to hit 45 more feet out, so that has to be at 90. And so we now know that this shot is between the two. The first one was 100, the second one was 80, this one is 90. And we also know, because we know the heights, that the second one is at, the first was at 25, the second was at 32, and this one's at 28. So they've put more loft on it. You can see the more loft they put on it, the shorter the shot gets. And so that's what they want you to see there. So, your assignment on this is on page 63, and it's 53 to 65 all. What I want to look at real quickly is that assignment. So we'll go to page 63. And so what you're going to do on this, they want you to graph each function and label the x-intercepts, the vertex, and the axis of symmetry. So let's just take a look at 55. So we know that the x-intercepts are at -2 and -6. So we found that. We can find the vertex, because remember the vertex has to be halfway between that, so negative 2 plus negative 6 is a negative 8. And negative 8 divided by 2 is a negative 4. We take that negative 4 and we substitute it in. So we got the x value of the vertex. So negative 4 plus 2 is a negative 2, and negative 4 plus 6 is 2. So we get 2 times 2 is 4 times 3 is 12, and 1 negative is negative. So our vertex is at negative 12. Our axis of symmetry we've already found. Remember that's always x equals the negative 4. And then it's a real quick graph, because we know we cross at negative 2 and negative 6. So you just put your points there, and then you go up to negative 4 and down to negative 12. Let's say it's there. And we connect it. So it's really easy to do those graphs. So hopefully you'll find this assignment fairly easy, and good luck on it.